So today I want to take a look at quantum numbers. And again, quantum numbers basically describe the possibility where an electron is at. Really, it's probability. So electrons are really too fast and too small to know exactly. We use quantum numbers to describe where they probably are at. That's probably the best way of, of saying that. Remember, electrons don't take these perfect circles around the nucleus. And so we use orbitals like s, p, d, and f to describe the pathway the electron is taken around the nucleus. We use n, that's our principal quantum number, to describe how far the electron is from the nucleus, etc. And again, all this has to do with energy. So depending on the quantum numbers that an electron has, it tells you how much energy that electron has. And there's going to be 4 quantum numbers. And so basically what we're going to do is describe an electron in a particular orbital by 4 quantum numbers. And again, this is applied to quantum mechanics and all that, in which basically you're using these complex mathematical equations to approximate where an electron is at. Always kind of keep that in mind. The first quantum number is n. This is called principal quantum number. It tells you how far an electron is from the nucleus. The higher the n, the higher the energy it has, the higher the potential energy, if you want to be very specific with that. So it can go from 1 up to 7. Second quantum number is going to be L. It's called angular momentum quantum number. A lot of times they use an cursive L. And it indicates really the pathway the electron takes around the nucleus. Again, these are numbers because we put these in these equations. We need numbers. And so it's going, L will be a different value for S, P, D, or F. And this is something we have to know. So for instance, now, if the electron is in the s orbital, we give the L value 0, P is 1, D is 2, F is 3. So again, we have to know these. It starts from 0 up to 3, basically. So if an electron is in a p orbital, we say, okay, well, that value is going to be L. If it's in a d, it's going to be 2, etc. Again, these will have different energies associated with it. So principal quantum number could be 1 through 7. L depends on which orbital it's at. Now, this other one, magnetic quantum number, it tells you the orientation in space. And we kind of talked about this before. S orbital only has one orientation, so it's only going to have one ML value. Only one value total. P orbitals, there's 3 types, so we're going to have 3 possible ML values. There's 5 types of d orbitals, so we'll have 5 possible ML values. And then F, there's 7 possible types of ML values. Again, it describes the orientation in space. Remember, for P, just kind of quickly here, it can be a long, like this will be a PY value. So ML will be a different value for that one. Okay, it does tell you the orientation in space. For PX, you'll have a different value for ML, etc. It goes from negative L to L. We'll talk about that in terms of the values. Again, depends on these values on top, whether or not L is 0, 1, 2, and 3. So this is something also we have to know. So say that an electron is in the s orbital. Well, the L value will be 0, and ML will be 0. So again, it goes from negative L to L, so L is only be 0. We know that because there's only one type of s orbital. So ML is only going to be 0. Now, if an electron is in the p orbital, we give it an ML value of 1. And so there's 3 types. There's 3 types of p orbitals, so you can go from negative 1, 0 to 1. That's what I mean by negative L up to L. So negative 1 up to 1. 5 types of d orbitals. So L is 2, so it goes from negative 2 up to 2. 7 types of f orbitals, it goes from negative 3 up to 3. So again, ML can have more than one type of values. Electrons can be equally distributed in any one of those orbitals. The last one is the spin. So electrons, they can spin either like, this is counterclockwise or clockwise. So it's either, that value now is going to respond to either plus or minus 1/2. So MS is pretty simple. the electron can either spin clockwise or counterclockwise, plus or minus 1/2 is the value that we get. One thing about it is that this is by Hund's rule. Every electron's got to have a different set of 4 quantum numbers. And this is also why there can only be no more than 2 electrons max in an orbital, because you can only spin clockwise or counterclockwise. So I just kind of jump into this. So we're going to write the 4 possible quantum numbers for an electron in the following orbitals. One thing about it, M and L are just going to have one value. They'll have one value, but the ML and then the MS can have more than one type. So that's something to kind of keep in mind. These only have one value. These can have more than one value. Let's take a look at this. And again, I'll try to give you the possible scenarios. If an electron is in the 2s orbital, this 2 really describes N. And then this S is going to be L. And remember, when an electron is in the S orbital, L is going to be 0. But again, that 2 there describes how far the electron is, which energy level is that. So N is 2. L is going to be 0 because it's an S orbital. ML can be, in this case, is going to be 0 because it goes from negative L to L, and L is only 0. It's only one type of S orbital. And then this last one is always plus or minus 1/2. Let's look at the next one. Let's look at a 3p orbital. N is going to be 3. That's a 3 there. That's simple enough. A p orbital, we give the value of L is equal to 1. The way it works is that, remember, S is 0, and then p is 1, 2, and 3. So it kind of goes up from there. There's 3 types of p orbitals, so I have 3 types of ML values. So -1, 0, and 1. And again, this kind of corresponds to like a px, a py, and a pz. Doesn't have to, but that's approximate what it does. And then, of course, ms is either plus or minus 1/2. 4D, N is 4. Again, L is going to be 2. So then we're going to have 5 possible values of ML, corresponds to each possible d orbital. So -2, -1, 0, 1, and 2. Again, that's 5. Then again, plus or minus 1/2. Last one is a 6f. So if an electron is in the 6f orbitals, write down all the possibilities. N is 6. That's going to be set. L is going to be 3 because that's an f orbital. And then this is where you have the possibilities. An electron can be in any one of these. Again, there's 7 types because it's an f orbital, -3 up to 3, and then plus or minus 1/2. So again, these are just ways for computer people, math people, to describe where an electron can be. You can never solve these quantum mechanical equations 100%, but you can just approximate the values for it.